In this section, we're going to be finding zeros of polynomial functions. Objective 1. Use the rational zero theorem to find possible rational zeros. The rational zero theorem says, if a polynomial has integer coefficients from a sub 0 to a sub n and has p over q, where p over q is the reduced to the lowest term, is a rational zero of f, then p is a factor of the constant term a sub 0 and q is a factor of the leading coefficient a sub n. The possible rational zeros are the factors of the constant term p divided by the factors of the leading coefficient q. How does this work in a real problem? For this function, f of x is 5x to the 4 minus 3x to the 3 plus 2x squared minus x minus 4. What are the possible zeros? Well, p are going to be all the numbers that divide the number 4. It is negative 4, but negative 4 is divisible by both positive and negative numbers. So p is going to be, so this, that's a0, a sub 0 is negative 4. So p is going to be all the numbers that divide negative 4. Well, those are the numbers plus or minus 1, plus or minus 2, and plus or minus 4. Since a sub n, which in this case that's a sub 4, is equal to 5, q are going to be all the numbers that divide 5. Well, those are the numbers plus and minus 1 and plus and minus 5. So this theorem says that if there is a zero of this polynomial and this zero is a rational number, then this rational number is going to be one of those or some of those. Plus and minus 1 divided by plus and minus 1, plus and minus 1 divided by plus and minus 5, plus and minus 2 divided by plus and minus 1, plus and minus 2 divided by plus and minus 5, plus and minus 4 divided by plus and minus 1, or plus and minus 4 divided by plus and minus 5. So my zeros are going to look like that, which this cancels to plus and minus 1, plus and minus 1/5, plus and minus 2, plus and minus 2/5, plus and minus 4, and plus and minus 4/5. So this theorem doesn't say that some of those are going to be zeros. Some of them, none of those may be a zero. It doesn't say if this polynomial has irrational numbers that are zeros or imaginary numbers that are zeros. But it says if a number is a zero, then it's supposed to be some of those. That is, no way 3 to be 0 of this polynomial. It has to be either 1, 2, 4 or 1/5, 2/5, or 4/5. Use the rational zero theorem to list all possible zeros for this polynomial 4x to the 5th minus 2x to the 4th minus x plus 2. So again, since a sub 0 is equal to 2, p are going to be all the divisor of 2, which is plus and minus 1 and plus and minus 2. Then since the largest a5 is equal to 4, then q are going to be all the numbers that divide 4. So the possible rational zeros, p over q, are going to be, and I'm going to do that a little bit faster, 1 divided by 1, so plus or minus 1 then 1 divided by 2, so plus and minus 1/2, then 1 divided by 4, or plus and minus 1/4, then plus and minus 2 divided by 1, those are going to be plus and minus 2, then 2 divided by 2 is 1, and I already have that written, so I'm not going to do it, and then 2 divided by 4 is 1/2, and I already have that down, so those are all possible zeros. Objective 2, find all zeros of the polynomial function. The polynomial function is 4x cubed minus 21x squared plus 29x minus 6. What are possible zeros? Well, the possible zeros are going to be p over q. So that's p would be products of 6. Factors of 6, those would be plus and minus 1, plus and minus 2, plus and minus 3, and plus and minus 6. And q is 4, so q is going to be plus and minus 1, plus and minus 2, and plus and minus 4, quite many. So p over q would be 1 over 1, or plus and minus 1. Then 1 divided by 2, or plus and minus 1/2. 1 divided by 4, plus and minus 1/4. Then 2 divided by 1, plus and minus 2. 2 divided by 2 is 1, I already have that. 2 divided by 4 is 1/2, I already have that. 3 divided by 1, so plus and minus 3. Then 3 divided by 2, which is plus and minus 3/2. And then 3 divided by 4, which is plus and minus 3/4. Then with 6 divided by 1, plus and minus 6. 6 divided by 2 is 3, I already have that down. And 6 divided by 4, that's 3/2, and I already have that down. So pretty much those are all zeros, possible rational zeros. Now let's see how to proceed. If I start with synthetic division, that can take me very long time, so probably handy is to use the remaining value theorem, which was substitute f of 1 and see is the remainder equal to 0. And if the remainder is equal to 0, I'm going to use that number. So I'm going to open my calculator here. So 4 times 1 to the third minus 21 times 1 squared plus 29, and I pretty much may not even write that 1, minus 6. What happened? Just 21 here. 21 times 1 is 21, so 4 minus 21 plus 29 minus 6, and it looks like my calculator is playing me back jobs. Okay, that's good. 4 minus 21 plus 29 minus 6, and the result is 6. So 1 is not a 0. I'm gonna try with negative 1. So 4 times negative 1 to the third minus 21 times negative 1 squared. Let's see if that's probably going to be something wrong here. Okay, minus 21 squared plus 29 times negative 1, and then minus 6. Let's see if I plugged it correctly. 4 times negative 1 cubed minus 21 plus 20. Yeah, so I have plugged it correctly, and the remaining is negative 60. So negative 1 is also not a 0. I'm gonna try with something else. Let's go ahead and try with 2. 4 times 2 cubed minus 21 minus 21 times 2 2 squared, then I have plus 29 times 2 times 2 minus 6, and it looks like I was lucky. I was able to figure out that 2 is one of the zeros. So once we have found the zeros, we're gonna apply synthetic division. The synthetic division was we're taking all the coefficients in descending order, and we go 4, negative 21, 29, and negative 6. We saw that 2 is a 0, so I'm going to divide by 2. Bring 4 down. 2 times 4 is 8. Negative 21 minus 8 is negative 13. Negative 13 times 2 is negative 26. 29 minus 26 is 3. 2 times 3 is 6, and 6 minus 6 is 0. So what we did at this step is we were able to factor this cubic equation by, we saw that 2 is a 0, so x minus 2 is a factor. And the remaining zeros would be, so that was polynomial power by 3. When we divided, we ended up having polynomial power by 2. So 4x squared minus 13x plus 3. Use synthetic division to find the possible rational zeros. Alright, so we can continue checking with more numbers, or since that's a quadratic equation here, we can apply the quadratic equation formula. So a is equal to 4, and b is negative 13, and c is 3. So x is equal to negative b, negative minus 13, plus or minus square root of b squared, 13 squared, minus 4 times 3. And all over 2 times 4. I'm going to use my calculator again. So just the under the root, we have 13 squared minus 16 times 3, and that's 121. So square root of 121 is 11. So here we'll have x is equal to 13 plus and minus 11 divided by 8. So 2 more zeros. I'm going to write them here. So first we figure that x is equal to 2 is a 0. The second is going to be 13 plus 11, which is 24, divided by 8, which is 3, is another 0, and another 0 is going to be 13 minus 11, which is 2, 2 divided by 8, which is 1/4. So we've got those 3 zeros. And I accidentally answered question C, which was use the quotient from defining 1 0 to find the remaining zeros of the polynomial function. Next question, find all zeros of this polynomial by first listing all the zeros and then using synthetic division. So P in this case is all the factors of 2, and the factors of 2 are plus and minus 1 and plus and minus 2. And the Q would be all the factors of 1, so plus and minus 1. So the possible rational zeros would be plus and minus 1 and plus and minus 2. So way lesser opportunities here, way easier. Use synthetic division to find the possible rational zeros. So I'm gonna copy the coefficients first. 1, 5, 6, and 2. And now try division by 1. If it doesn't work, I'm gonna try division by something else. So if it's 1, we bring 1 down. 1 times 1 is 1. 5 and 1 is 6. 1 times 6 is 6. 6 and 6 is 12. And I can see that 1 is not working already. There is another theorem that I don't teach in this class, but the number of sign changes here is going to tell me if I have a positive 0, and I see that there is no sign change. That means I'm not gonna have a positive 0. Because agree with me that if that's a positive number powered by 3 and I'm adding numbers powered by something, I keep adding numbers, there is no way to get to 0. I keep addition. So I'm gonna try with the negative numbers. Negative 1. Bring 1 down. 1 times negative 1 is negative 1. 5 minus 1 is 4. Negative 1 times 4 is negative 4. 6 minus 4 is 2. 2 times negative 1 is negative 2. And 2 minus 2 is 0. So it turns out that one of the zeros is actually equal to negative 1, which means x plus 1 is a factor of this polynomial, and the polynomial look like f of x is equal to x plus 1 x squared plus 4x plus 2. Now at this point I don't have another choice but apply again quadratic formula for a is equal to 1, b is equal to 4, and c is equal to 2. I know that it is possible, generally it's possible negative 1 to be one more time 0, and me trying with negative 1 one more time, which 1 brought down is 1. Negative 1 times 1 is negative 1, 4 minus 1 is 3, negative 1 times 3 is 3, negative 3. But negative 1 is not a 0, and negative 2 is also not a 0. Negative 2 is also not a 0. Negative 2, negative 2 times 2 is negative 4. See, it's again not a 0. So, oops. That's not gonna work. So I'm going to quadratic formula. Quadratic formula will x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. It makes sense to write the formula, by the way. It's easier to substitute. Okay, 2a, a is 1, so just a 2. Okay, so that's negative 4 plus or minus 4 squared is 16, 4 times 2 is 8, so 16 minus 8 is 8. Divide by 2, and I see that the zeros actually were irrational numbers, which that's why I couldn't find them. Negative 4 plus and minus. Now, what's square root of 8? That's square root of 4 times 2. Divide by 2. So that part, this 4 here, can be taken root of. So that's negative 4 divided by 2 plus or minus square root of 4 times 2 is 2 square root of 2. Divide by 2. And the 2 divides the 4, so that's negative 2. And the 2 divides the 2, so that's plus or minus square root of 2. And we found 2 more zeros, which this is cubic function and that's the most it can have. So we found these 3 zeros, one of them rational and 2 of them irrational. Solve the polynomial equation 2x cubed minus x squared minus 14x plus 7. So again, we are going to use the same rules. P is equal to multiples of 7, so plus and minus 1 and plus and minus 7. And Q is equal to multiples of 2, so plus and minus 1 and plus and minus 2. So all the P over Q's would look like plus and minus 1, plus and minus 7, plus and minus 1 divided by 2, and plus and minus 7 divided by 2. And I'm gonna start with 1/2. See if 1/2 is a 0. The coefficients are 2, -1, -14, and 7. So we bring the 2 down. 2 times 1/2 is 1. So I put the 1 here. Minus 1 plus 1 is 0. 0 times 1/2 is 0. 0 minus 1 minus 14 is -14. -14 divided by 2 is -7. And 7 minus 7 is 0. So it turns out that x is equal to 1/2 is a 0. It's one of the solutions. Well, this means this equation become x minus 12 minus 1/2 times 2. So that was equation powered by 3. Now it's reduced to equation powered by 2. Notice that x times x is missing. So just that. And we can solve this the remaining quadratic equation. First of all, we can factor the 2 out. So we have to solve the problem 2x squared minus 14 equals 0. We can divide by 2. X squared minus 7 is equal to 0. X squared is equal to 7. Take square root of both sides. X is positive and negative square root of 7. So together we end up having cubic equation, 3 solutions. And I'm gonna continue with the next objective in the next video.